Alright, hello, welcome back to Runic. Alright, let us see where we left off. I think, last time we did arrays. So you can define arrays, you can access array elements, and yeah, that went pretty well, I think. Okay, I'm not sure about this though. We had some issues with this part, I think. I don't remember exactly. Yeah, I think it was the compilation issue, because if you try to say capture an output 0, let's say, that should be 1, right? So, but unsupported binary. Yeah, so I think that there might be an issue with that, with the capture output 0. Unsupported binary. Okay. Yeah. Wow, that's a lot of a lot of things happening in the debugger there. Unsupported binary expression. So basically, oops. Maybe I should skip. Maybe when you continue, it should like skip printing out, because I think that takes like a long time. So we get to here quicker. But okay. I mean, now it's kind of nice because you can always move back to see the whole history, but maybe we don't need to print it out. I don't know. Anyway. Or maybe we could just print everything at once, or something like that. But yeah, so this one is what's happening. So arithmetic R2 equals, so unsupported binary expression. I mean, it might be because of this here. So identify ref could then refer to something that we can't add. So if we go to 0, 120, well, actually let's just comment everything out. Set, oops, this part. Well, still takes like a long time. 0.73. Well, I mean, it does take a long time since we spawn like 3 processes. That's a lot of things happening. And now I forgot which one it was. 0.73. Okay, so identify ref is SF plus A. So let's look at the stack. This is for thread 0 plus A. Okay, so these aren't like these numbers should be hex as well then. But plus A, so we're down here. Pipe 8, yeah. So No, I think the issue. So pipe 8 plus 0. This is what's the issue here then, because why would this be set to be the pipe? Yeah. So there's a bug. I'm just gonna write that down. Like there's a bug with arrays that have these expressions in them. So I'm gonna write that down as a bug here. Arrays with executable calls as elements cannot be accessed with element access operator. Yeah. All right. And I'm pretty sure it's still going to be an error if we do this. Yeah. But you can define it and just make sure that the things, the captured output is not, or I mean that these echoes are not like echoing out to standard out. It's actually captured in a context, kept in memory instead. All right, so what else do we want to do? Also, this is kind of interesting because it, like, how would the order of operations work here? And there's no I don't think there's an equivalent to this in Bash, unless you use like the operator, like the dollar. Hello, Sadhu, welcome back. How are you? I think you were here yesterday, maybe. Yeah, like this, which I think works. No, wait, no, that doesn't work, but this works, I think. Yeah. So you have to do like this to get, but it's possible, I guess. The question is, like, what would be the order of operations? I guess it would be like one after the other. I guess maybe we could try. So let's do let's say this is 1, and this would be like sleep 2, echo 2. I mean, I guess we don't really see the result because it's all bound to an arrays. I mean, we could also do this for this t array.log. Which will write it to the array, but it will also write it to the file there. I hope it like appends. I guess we'll see. I don't really know how it's doing it, so let's do this again, because now we'll see what the cat. Oh, it just overwrites it. Okay. Are you trying that stencil? Yes. Okay, nice. It's good. Okay, cool. Still learning. Trying to finish studies. Probably work on that. Yeah, alright. Yeah, I'm not sure how many companies are using Stencil.js. Like, I don't even know. Like, but I would, you know, the most, I would say the most popular right now is React. So, like, if you learn React, you have a pretty good, you know, chance of finding or you know, I guess you would have a better chance of finding work with React, I think. But you know, Stencil.js is very interesting, and there's nothing wrong with having some personal projects with that. I tend to have a couple of personal projects that I'm developing just to try out different things. But just as a career advice, React is like the most popular right now. And there are other things like, you know, Angular 2 or whatever, I guess they could just call it Angular now. I'm not sure how popular that is though. And of course you have Vue. I mean, those are the three most popular ones, I would say, right now. It's fast, which I like. Okay, React is kind of slow. Do you mean like development time or runtime time? Because yeah, if you build like React naively or yeah, you can easily make a very slow React application, like runtime wise. But development wise, I would say is like what you're most used to. The thing for me is I'm not really trying to get a job. Okay. So are you not gonna get a dev job after the studies? You have to build prod every iteration. Okay. How do you make this append A? Okay. So the first one, I don't know. Let's just do this. Remove, and then append. Okay, so the array, of course, is evaluated to 1, 2, 3, and then we look at the logs to see the actual order of operations 1, 2, 3. Okay, so they are actually evaluated consecutively. So, or I mean, no, I think that's the word. Yeah, in a sequence. So basically, this is evaluated first, and then you wait for this to evaluate. So it's not like they're evaluating in parallel. Okay. Well, that's good to know, I think. And then we can, let's also cat. So this would be the array. And then we say log. And then we remove that. Argument mixes string and array. Okay. Sure. Now the first one, like I want to see, like, because I think if we remove it, like if you run this twice now, is that gonna be like an error? Oh, I see. It also appends like an. Oh, I see. I think it's because echo does a new line. What if we say printf instead? Yeah. Now we get an error for remove. Oh, now we get this instead. Okay, I guess it doesn't matter. Let's do this. Yeah, all right, cool. So that, interestingly, the array actually removes like the, I guess space is like a delimiter or something. I don't know. I have no idea how array works. You're just returning to school again. Okay, well, I was thinking more like you know, the future. Like I was thinking like, you know, if you want to focus on something that actually lands you like a job, then React is like a very popular, like it's used everywhere. You know, compared to Stencil.js, which I mean, I don't really know how the landscape looks for that, but I would guess that React is probably way more popular. So it's just that was all I'm saying. Hello, Subidara, what's up? I wanted to ask you something. Can I send a video here of my channel? I just wanted to show my latest project. This bash code looks so complicated. Yeah, sure. Are you in my Discord? You can send it on the Discord if you want. And I told you yesterday why I prefer this. Usually, I understand React is useful. It has more backwards compatibility, but for my project, doesn't matter. Yeah. I'm not saying you should make your project in React. I'm just saying that if you're studying to get a job later, then React is a good choice right now. And Next.js uses React, so Next.js is also a good choice. I would believe, like there's a lot of companies using Next.js. I mean, I don't have the statistics, but from what I've seen and from my experience, Next.js is a popular thing right now, and also but also not really just only that kind of platform or framework, but also the kind of style in which Next.js is doing things is also popular, where you have like, you know, file structure as routes and other features there like server-side rendering and stuff. Yeah, this bash code, I was basically testing how arrays work. Also, I want to see, is there like a silent F? Ignore non-existent files. Yeah, let's just do F. So that will not render it, some kind of weird error. Okay, so basically what this is doing is I was testing if when you create an array, if you have, you know, this is an array with 3 elements. This is the first element, this is the second element, and then the third element. And basically all of these elements are you know, executable calls. And so what I wanted to check was the order of execution here. So it turns out that bash, because, okay, so if I explain the setup here, it's basically you have the first element is just a printf, and then we pipe that directly. So it's basically just running this, and then we have this t piping into t here, which appends to a log so that we can see what is actually written at which point in time. Okay, because yeah, this, since we don't get any output, we don't see which one is happening first. We have to pipe it to a log to see like what is happening first. Okay, so basically the first one is just printf1, and then we log it. Second one, we have a sleep here, so we can see that, okay, well, if this was happening in parallel, then we would get some kind of out of order operation execution here. So sleep 2 and then print 2 and append it to the log, and then the third element is print 3 and then append it to the log as well. So that's, so as you can see here, the array is echoed out here, and the array is of course just 1, 2, 3, but the log is also 1, 2, 3, which means that this is executed first, and then we wait for that to finish before it executes the second one. It waits for that to finish and then executes the third one here. So that's that's what I was trying to test here, which just to see how the order of operations work, which I'm not sure if we're actually doing the same thing in my case. And since we don't have redirections, but we do have, I mean, we can call T. So, I mean, for this one, I can just say T here and do the same thing. So we can do like remove force IR_array.log, and we T that into log. We T this into log. Oh yeah, I should append as well. So we can do the same test here to see the order of operations. And 3 T into array. So here we also need to sleep 2 as well. There we go. So that should be the same thing. However, actually, I'm not sure how sleep 2 will actually... I mean, I think... so if I would guess here, I don't remember exactly, but we're basically just... I don't think we're waiting for each one. I think we're just spawning them up. Well, I guess we'll see. So if we... let's just remove everything else here. And then I want to cat the log and then remove it as well. Oh, we get some weird error here. Interesting. Okay, I'm gonna try just doing sleep to echo to T A I R array.log. So it does this also. Okay, so this is an error. I'm gonna remove sleep 2. I'm not sure if that's the issue. Probably not. No, we still get out of bounds. Okay, well, so something weird is happening with this pipeline here. Did we break the pipelines? Okay, so something is wrong with the pipelines. My current project is very client heavy, so just want a web components thing. Okay, nice. I see, I see, I see. How do you implement syntax highlighting of your language? So I'm implemented it using tree sitter, which I mean is specifically for NeoVim. And to be honest, I didn't actually like the setup here. Was, well, the AI actually scaffolded this, and then I've added a little bit along the way, but I haven't really updated it for a while, so there might be something wrong here. But basically, I'm using tree sitter with NeoVim to create a bunch of, you know, how it's supposed to parse the code. And it's got all these different operators and stuff. And then there is syntax rules. Where was this happening? There was like a file I had that provided a bunch of highlighting rules. Highlight, yeah. I also went through a bunch of different iterations of this, but basically, yeah. So here you get highlights. This is like the tree sitter queries file, and so how it basically works is that NeoVim already has a bunch of built-in highlighting things. Oh, all right, see ya. But yeah, I guess I can continue explaining. But basically, NeoVim has a bunch of like built-in highlighting. You know, you have these things like keyword. These things are like built in, I believe. So if you just map the correct things, you will it will get the highlighting that you want, basically. Because the highlighting is already has like a theme and all that probably set up for you. But yeah, anyway. Okay, so something is wrong with the pipelines. I'll write that down in to do here. So pipelines are broken again. Okay, so we can't really test this here. I'll just revert this file here. You know, let's just. There we go. Okay. Now, where were we? So, yeah, okay. So we got a couple of issues left with arrays, but they are basically, I mean, yeah, arrays, they do work. It's just that it doesn't work for specific things, like having, you know, you can't access an array element if it has an execution result in it, because it's not compiled properly there. But I'm gonna leave that for now. I'm not sure if that's gonna be in MVP, because that's not really an important, I guess, feature for me personally. So I will leave that for now. I'll roll it down in bugs. What I want to do is I want to go to for loops now and figure out. The last time I talked about having like AI actually give me some suggestions here, but I think that I don't want to do that because I'm using AI basically for all capacity of AI to do something else right now. So what I'm gonna do is I'm gonna try and figure out something here on my own only. So maybe shy, so it's hard for me to make content. All right, cool. I mean, I think maybe it's a good way to train that. I was, you know, I was probably the most shyest person ever. I don't know. But I was like, you know, I couldn't really talk to anyone basically for a long time. But it's just a matter of training. It's just a matter of exposure and training how to actually interact in... I mean, I'm still not great at social interactions, stuff like that. But, you know, you basically build up, you know, the skill. It's basically a skill that you learn and that you get better at. And that will give you confidence to speak to people, basically. But you know, I still have a lot of trouble with it. But you learn, you live, you learn. Spoken English is horrible. I mean, my spoken English is also pretty bad. Like, but the more you speak, the easier it gets. And I think also, like, if you start streaming and people, you know, watch you, they're probably watching because they enjoy it. I mean, I guess people do that to me. I don't know. but so you probably don't have to worry about it, is what I'm trying to say. Yeah, no problem. I think just try it out. And also, like, yeah, I've been streaming, like, how long have I been streaming now? For like 1.5 years or something like that. No, not even that. Like 1 year, I think. And it's I mean, I knew from the start that my area is very niche, so I wouldn't get, like, you know, a lot of views or anything like that. So I don't really try to think about trying to get a lot of views or anything like that. I'm just doing what I enjoy, and if people want to join in and watch and you know, have a conversation, that's great. You should. I'm seeing that as like a bonus to what I'm already doing, and it helps me keep me motivated to continue with these projects as well. It's really nice when people, like, join and say that, hey, this looks cool. Like, yeah, do that. Good luck with that. Unfortunately, I don't really watch other streamers. Like, I don't really watch... I mostly watch VODs of, like, gameplays and stuff. I don't really watch, like, development streams. I've done it a little bit, just to see how other people are doing things. Because I think that could be, like, a good way to learn as well. Like, if I've been doing something wrong the entire time, and then you find someone else who does does it the correct way. It's always good to learn. I'm always happy to learn stuff. The game I was working on. Which game? Was it the shoot 'em up or the Metroidvania? Yeah, thank you for the compliment. Okay, but for loops. So the thing is, like, this would be the most, I guess, iconic for loop to have the range, but we don't really have ranges as a value right now. I think I'm gonna start with array iterator, probably. Let's just go. No, compiler. Also, for some reason, the LSP just started working here. I don't understand really why, but okay. Let's just remove this file from the things and these ones as well. Okay, I'll remove you as well. There we go. We're free of errors. Because of a kind of understanding, even though I don't know Zig. Oh, nice. I mean, I think that goes to show that Zig is like, I think it's probably like one of the easier languages to learn, like just to understand what you're looking at, but then to actually use it and understand how to build things. That's where it gets a little bit trickier, just because it I mean, you're used to. I thought you said you were like C++ or something. So you're probably used to, like, I mean, you're used to manual memory management and all that, and pointer errors and stuff like that. So for you, this language is probably pretty easy to understand everything, basically, because it's basically just like C with a different syntax and a lot of nice features, I would say. I really enjoy Zig. Okay. So the for loop, right? So let's go compile expression. The for loop is an expression, so it's not a statement. It's an expression. Basically, everything should really be an expression almost. It's like the bindings are probably the only things that's supposed to be a statement. The thing that this or the type and the type binding there, of course. So, but the return statement, I'm not sure if that's even, that might also be an expression. I haven't really done the return statement. It doesn't actually work, I don't think. Yeah, it does exit, so it's like, that's not even correct. I don't know. Anyway, maybe it is actually. But anyway, so for loop is actually an expression, which means you can bind something to it. I think it's for expression. Compile for loop. Yeah. Okay. The comment thing, actually source. All right. Implement a little game or something. Might try it for fun. Yeah. Yes, I encourage you to do that. I mean, and then you can use Raylib because it's such an easy language. It's easy to import and it's easy to use. And for allocator, I would just I don't know, I would just yeah, if you need any tips on allocating stuff, We could go through that a little bit if you want, like the different allocators. Because I'm still exploring that also. Like, I want to find a way that makes like that you can have like a pattern in your head. Like you can, if you follow this pattern of allocating stuff and doing things, you have like you have a solution for every issue or every problem that you face. There's built-in allocators, yes. I mean, yeah, in the standard library. So it's basically whenever you want to allocate something, you have to use an allocator. And okay, well I can show you. I can show you an example here. So I mean, you can also put things on the stack, but you know, sometimes you want to put it on the heap. But let's say I'm just gonna say like allocator example. So let's say we have main. So you import the standard library like this, and then we have the main function. So this is a proper, you know, zig program here. And usually you would create. Okay, this is kind of the old style. I haven't really learned how you can do it the new style. Actually, no, forget about that. What you can do is you can basically just use the page allocator, which is, this is kind of like an already usable allocator that you can use. You usually have a variable just called allocator that you can set to any kind of allocator. So, or yeah, so that is the allocator that you're using currently. So you can have this page allocator. Now you can use that. What the page allocator is doing is basically it's just using, yeah, it says here on operating systems that support memory mapping, which, you know, if you're using Linux, for example, I think there is a syscall mmap, which is using to do things, and that has support for allocating things in like yeah, it is just, you can just allocate things there, and it gives you an address back basically. I'm not sure about Windows though, but yeah. For on operating systems that support memory mapping, this allocator makes a syscall directive for every allocation and free. And I guess what to think about there is, like, if you do a syscall for allocation, it's probably gonna be not the fastest way to allocate something, maybe. But if you're not worried about that, you can just use this page allocator directly like this. And then to let's just show how to allocate something. So basically, let's say you have a struct. Let's say you have like a game object or something, and then you have like, I don't know, health, max health. Let's just do something like this. Okay, so then let's say you want to allocate a bunch of these game objects. So you would have like game objects. Now you probably want to store this in like a game struct or something. Windows has virtual alloc. Okay. So you could use alloc for. Then you get like an array of things. So you supply the type, and then how many you want to store. So let's say 100 here. Oops. And since this allocate, you can look at this type here, and it returns an error union. So it's either, this could be an error, so then you have to add try here as well. So now if we look at the type of game object, it's gonna be an array of, or a slice technically. This is a slice. It's basically like an array with a known, or yeah, runtime known length. It's basically just a struct with a length and a pointer. But it has like built-in functionality in the Zig language. If you remove try, this would be like an error union. So you have to say try here to make it into this here. Now what would happen if this fails? This fails only if, like, if you're out of memory. And so then, since we're in main here, it would be like the global kind of error handler that's gonna catch this, which by default is some kind of thing that Zig provides. But you can actually change that if you want. But yeah, so it will basically just crash and show you an error there. But anyway, now we should have like a list of game objects, which we have 100 of. Now you can populate this, like if you look through game objects, you get like the game object out here. So you can actually iterate through the slice like this, and to be able to change the contents of the array or slice, you have to add a store here to make it mutable. So now we can set, let's say we just set max health to 3 or health to 3 or whatever, something like this. Or we could just set game object itself to the initialization syntax like this, so that we get the whole thing. Because you can have, let's say you have like an init function here that returns a game object, and then let's say you have like max health, health equals max health. So just a convenience function to initialize a game object here. And then over here you can actually just say init 3. So we're initializing every game object with 3 max health now. So this is, I've not actually seen this in any other language, this kind of syntax, but this is called a capture. And it's really simple. It's basically just binding an identifier that we make up here. You can name this anything you want, to the element that we're currently iterating on. So if we would, let's say this would basically kind of be like this. Let's say we have a range from 0 to the length of the objects, and of course I have to discard this, but don't ignore this part, or actually don't ignore that. We get I out here. But basically what this is doing is kind of like this. You get game object equals game objects I. So this is basically a shorthand almost for this. So, and what is pretty cool as well is that you can pass in multiple things here. So you can pass in a range here, and then you can also get that out here. So now we have I, which is the index of the current iteration here. So that's how you could also, like, let's say you want to iterate through game objects, but you also want the index for some reason. Then you could just add this as a range, and you get an index out like this. So that is pretty cool. And you can add however many things you want here, basically. So it's a proper like low-level language. Yes, it is. I mean, it's as low-level as C. You can even write assembly code. I once did on stream. I did because someone challenged me to do like hello world without the standard library. So you can do that if you want, and then you can use like assembly code to just call a syscall. Yeah, so that is like, so you allocate this with the allocator, and then you can also free it as well. So I'm gonna free this. So this would usually be the pattern here. You would allocate something, and then you defer and free it. And what defer is basically it's gonna queue something to happen at the end of the scope. So this will happen at the end of the scope of the current scope. So if you would have like a return down here, this would also execute at this return, or it would execute. Well, now it executes over here at the end of this function. How do arrays work? Yeah, so this is a slice, which is kind of like an array, and you can still like, you know, you can access elements in them like this. So, you know, you can so basically, okay, so basically what's happening here, this is all low level, right? So all this is a pointer and a length. This slice here, the length is 100 and the pointer is whatever we get from alloc. Yeah, it's a slice. An array in Zig is a comp time known length. It has a comp time known length. So you can also do like objects as an array. Like in this example, it would probably make more sense to have this in an array. I don't know. It depends on the size of the game object if you want to put it on the stack or not. But this would put it on the stack. So you would have like an array 100 game object. No, the type. So yeah. So this is the type. The type is 100 game objects. And I'm just going to set that to undefined for now because this is a way to kind of initialize. So in C you would just have this, right? But in Zig you can't. You have to initialize everything. So if you haven't initialized it, you have to initialize it to undefined. This is the same as just saying I want space for 100 game objects here. What are we making? I'm just showing like a basic way to use allocators in Zig. It's kind of like introduction to Zig almost here. What's the exclamation before void? So this means that it can be an error. It's an error union type. So if you just had void here, that means there can't be any errors happening in here. Although with a bit of caveat, because there could still be segmentation faults and stuff like that. But there's no like typed errors, I guess. Because basically this part here, for example, this could result in an allocator error, or you don't really see the type here. This error type, so it can be an out of memory error. And how this is the type, the return type of allocate here, alloc. What is Zig? This is Zig. It's a programming language, a low-level manual memory managed programming language. So this type means that it can be this error, or it can be, you know, success with this type here, which is a slice of t's, generic type here. So that is allocate. And now this is an array here. So this is a slice and this is an array. And the arrays always have like a comp time node length. So this is a comp time node length here of 100. And then you can also, like arrays, you can also iterate through the same way here. So that is exactly the same syntax for iterating through an array. But the difference is that this is stored on the stack and this is stored on the heap. Well, I guess it depends on the allocator actually. The allocator could potentially store it on the heap, but this is the page allocator, so it would store it on the heap. And then you have to free it as well. Well, you don't have to free it, I guess. It would be a memory leak, depending on, like, this is the end of the program, so we don't really need to free it, you know. But if you don't want memory leaks, it's good to know about free. I mean, it's the same pattern in, you know, malloc and free. Okay, so usually the pattern is that in the main function you would define an allocator, and then the allocator is basically passed around everywhere. You can also have objects that have an arena that would take care of basically their own memory. So you could have, but this object doesn't really allocate anything, so it doesn't really make sense. But let's say you would have a list of, I don't know, targets, which is like let's say it's a slice of game objects. Now we can say actually you can provide a default value, which is an empty slice. You can always define an empty slice like this, because, you know, something with lengths of 0 doesn't really have a place in memory, so that's fine. But then you can have an arena allocator, and when you initialize, then we can provide an allocator. We provide an allocator, and then we can initialize an arena here with the allocator as a child allocator. So what this will do is basically you would store it. The arena will kind of remember everything that you've allocated, and then when you deinitialize, so we have a deinitialize function. We simply call arena.deinitialize. And let's say we want, so how do we use it? Well, let's say we have an add target function. And then we have a target that we want to add to this list. Now you would probably, maybe you would use like pointers here or an ID or something instead of a game object, but the point is to show how the memory, the stuff works. So basically, I mean, let's just say that we want to add something to the target. Now normally you would probably use like an array list instead of a slice, actually, because it's like pretty, I mean, yeah, it becomes tedious to have to like reallocate a new list, copy it over, you know. So you would probably use an array list instead. Let's just do that. So you have like an array list of game objects. Okay, so this is probably how you would do it. You would have an array list, but that also requires an allocator when you want to add a target. So you want to append now the target, but we also need to supply an allocator. So the allocator would come from the arena at this point. we have to try this as well, because this could be an out of memory error. Okay, so you would have this function called add target. Okay, and you supply the target. This appends it into our list here using this allocator. But then you never really have to free this target array list. You can just free the whole arena. Yeah, I'm just showing a little bit different strategies here. The arena thing is pretty nice because you don't have to free up every individual thing that you allocate. You can just allocate a bunch of stuff with the arena, and then when you're done with that whole object, you can just deinitialize the arena. It will free everything that the arena has initialized. Yeah, maybe I was getting too ahead there, but so now we have to actually pass this allocator in here, and then we defer. Actually, the defer now we have to change, so we can defer. We can loop through the game objects. Actually, let's remove this array here. And then we say game object.initialize, and that will actually free up. That will like deinitialize the object and free up everything that it has used, and then we free up the actual list here as well. I mean, for Snake, you would probably have like a bunch of apples, and as I showed before, you can use an array list. And let's say you have like an apple struct or something. So you would use like an array list, because that array list is dynamic list. So you can add more things. You can append items into it, and then you can also, pop if you want to remove. I think the last item you can do swap remove for like a quick remove of the index what you want to remove. You also have ordered remove. Yeah, so you can basically look around in the different methods to see what you can do there. But yeah, you would probably do something like that and not have like 100 allocated objects. Although this, if you want to do it like this, you want to have like capacity of 100, you can also do that. So you can do like try array list in Apple, and then you would do init capacity, providing an allocator and a number. So that will actually give you capacity of 100. So we'd allocate space for 100 apples, so you don't have to keep expanding the list. It's just a bit of optimization, basically. I mean, yeah, I think I'm going too far ahead, maybe, but yeah, as I said, like usually you create your allocator at the root of the program. And there you use that allocator throughout the program to allocate a whole bunch of stuff. So you have to, if you want to allocate, things on the heap, you have to have an allocator. And the page allocator is like a very easy way to just get started. Okay. Okay, anyway. Yeah, I think it's good to get like just a if you're not used to that pattern, it's good to get some kind of introduction at least, so you have some idea if you want to figure that out. But there's also, I think there's a lot of good videos on YouTube actually. or well, maybe not a lot, but there I found a series, which I guess is like outdated now for some of the things. I'm not sure, but there was like a deep dive series into Zig, which I don't remember now what it was called, but it showed like a very detailed introduction to Zig, of all the concepts and everything. So if you search for that on YouTube, you'll find some tutorials and stuff. Yeah, just keep in mind, like if you install like the latest version and something doesn't exist the way it's presented, then yeah, that's I guess an issue. But anyway, hopefully it's like updated to this latest version or something. Okay, let's see if we can think about this for loop. I've been putting this off, I feel like, a little bit. I actually don't have a clear idea of how to do this. I mean, we're gonna be using jumping and stuff. So basically what we're doing is we're trying to create a for loop in our IR language, which is sort of almost like assembly language, but not really. And yeah, so I mean, I guess we would need okay, so first off, the for expression. What do we have on the for expression? We have a body, which is, you know, the body of the for loop, that is going to be executed in, I mean, it's going to be its own like context and stuff, probably. It's going to at least have some declarations, its own like declaration scope for identifiers, because it's going to be, you know, the capture is going to have some bindings in there. And then we have sources, which are what are we iterating over. So it could be arrays, it could be any number of arrays, it could be any, like a mix of arrays and anything that is iterable. So arrays and ranges is what we have right now. So, and then captures are like, how do we actually capture those things? So it's like a zig loop, for loop, basically. So basically what I show you here, where it disappeared. But yeah, so the sources need to be compiled, and we need to create like iterators for those, I guess, somehow. I think what we're gonna do is we're just gonna start with support for one array. So we're gonna say if is more than one, there's gonna be some kind of error here. Do we have report here? This, I'm just gonna say like not, wait, not implemented. For loops with multiple sources not yet implemented. Okay. Also, let's grab the source. I'm just doing this to make it like I want to make the most basic structure of this first, and then we'll figure it out. So the source, so the type of this needs to be an array, can't be a range. Now, of course, this could be something else that compiles into an array. So I think what we're going to do is we need to compile this source first. So source result is equal to compile the source. And then we're going to check if this is an array type. Well, okay. We actually need to check. So we don't have a way to check if it's like a generic. We don't have a way to check right now if it's generically an array type. So we have to do like this. If it's a location and if the location options type expression is equal to an array, right? Yeah. Then we're good. So it's like if this is not true. So if this is not equal to location or this is not equal to an array, then we should also have an error saying for loops with non-array sources are not yet implemented. Okay. So now we know that the source is an array and we only have one source. So now we need a way to kind of iterate through that. And I think it makes sense to store this source in a ref, probably. So we can make sure we have it kept around in a stable place. Source ref, or just source. Whoops. Now, this would be, let's just call this expression. Okay. So we have that, and then we need to set that to source result. A lot of sources here. This is like 3 different sources, source meanings. This is the source of the expression. This is like, so we can see where this instruction came from the source code. So this is kind of like the source code. This is the for loop source ref. This is the for loop source compilation result, and this is the value source that we also call source. So it's kind of like 4 different source meanings in the same line of code. Okay. Yeah, we set that, so now we have that stored in source ref. And we might pop that later. Now we need to like create the for loop basically in our IR language. So I think we create like a label. So this would be the for label. New label for, and the address is abs. I think. Yeah. So basically, yeah, we're creating like a label. So this is like a unknown instruction address. Well, it's kind of like a marker for where we should jump to when we want to do things. I'm not sure if this is the correct place for it, because we want to set up. We want to know basically how many iterations do we need to go through, I think. Actually, what kind of constructs do we have here for this? Because we have like if, compile if. This one uses what? Let's do like no else. We have like a conditional jump. Jump if. This is the condition. Jump if means like you can kind of reverse the condition. So like we're jumping if it's true, or do we jump if it's false? This one jumps if it's false. So basically skipping this code if it's false, which makes sense for an if without an else as well, or an if then clause. So we basically jump like, yeah, we have the conditional jump. Now the condition is just, well, for an if expression it's just this expression in the if, but for the for loop it would be something like have we iterated, like, okay, let's do it like this. Let's just have like a counter ref counter, so for counter, and then I want to have also how, like, what is this called? Like how many iterations do we do? Iterations, I guess 4 iterations. Right, so counter should start at 0, of course. So we'll set this to 0. Okay, and then iterations need to be, we need to calculate that. Somehow. So like, but now we know that the source result is an array, so we should be able to just look into the array then. Yeah, so we can get the length of the array by looking at the first, looking at, because the array is basically just a pointer, and the first element of the pointer is the length. Welcome back, Subadara. So that would be, so let's use, okay, first of all, how would we get that? That would be, from location, source result. Actually, it would be source ref. Dereferenced. But that would just give us the pointer to the array. So we need to dereference that as well. So actually, just let's use R2, which is a general purpose register, to first set this there, and then we're gonna use from location init absolute register R2 dereference true. Now we could probably also use some kind, because this is like this is the way to get the length of the array. I would want to have a more generic way that we can reach into kind of like a struct or some kind of data, structure to get different, fields or something, data from that structure. But so this is like we're doing it manually here, basically. We're reaching in, getting the length of the array manually, basically. But it works. So now iterations are set to the length of the array, and counter is set to 0 to start with. So I guess what we would do is we would check actually we would need like a label that is lazily known. So after label, so for after, and this would be like unknown for now. So we need the label to be able to jump to it. We're referring to it now, but the actual address is unknown, but we'll actually mark it later. So first I think we're jumping conditionally here. So the condition though, what is the condition? The condition. Well, I mean, the condition is just going to be like, we want to check if the counter is less than iterations. Yeah. If it's equal, we're done. So it needs to be less than iterations. So let's create. Do we want to? So how do we do that? I think we do actually, let's go to compile if. No, well, so this condition is just an expression that we get from the thing, but now we have to kind of create our own expression. And maybe compile that. Or do we simply... No, yeah, because we have like compile binary. It will be some kind of binary expression that will be logical, or one of these, yeah, less than. So basically we would do something like this, compare, like, yeah, we have the compare instruction, but I think I wanna just create a binary expression probably that is going to be compiled probably. Or we can just do the compare directly. We could add this directly here. Yeah, we'll probably just add it directly, actually. There's no like compare. We could probably add that. Compare. What do we need? So we'll add the instruction. No, this would be important, I think. Actually, yeah. So we have. So we need like left and right. So this would be operator. Left and right, and then we also have result, which is a location, I believe. Yeah. So there we go. So this would be the operator, left, right, and then result. There we go. So we could do compare. Actually, I want to change also here. So we'll do compare here instead. Binary operator. Operator would be less. Only less. Why do I don't get... Oh, first we have source, right. Then less. And then we have left-hand side. Left-hand side is... so counter should be less than... iterations. Now we also need to dereference these. Wait. From, yeah. What else do we have? And then where do we store the result? Well, let's just create a ref for that as well. No. So, check ref, I guess. Do you have any plans to go on the game development? Yes. I'm pretty close to MVP of Runic, and after that I will go back to my Metroidvania game. I think. Maybe I'll do like a quick, small game in between, like a very small, like couple of streams. Small stream or a game before that, just to get my hands dirty a little bit with game development. But yeah, I'm gonna go back to the Metroidvania game because yeah, I really wanna just finish that. Hello, Titsy. Welcome back. Are you gonna stream? What's the stream about? Check ref. So for check. Okay, so this ref is gonna store the result, or we could also use, we could just use the I mean, we could just use R2, I guess, as well. We don't really need a ref for this. From location, no wait, it's always a location. So init register R2. Let's just store the result in R2. And then, so now we have the result should be in R2. So here, now we'll say condition should be a result. So that would be like from location, init R2. Okay. And then jump if. So if it's less than, it means we still need to iterate. So we're gonna jump is false. Jump if it should be if that is false. Destination to jump to would be the after label. Yeah, that's the instruction. So that is the after label. Okay. Right. And here's the beginning of the for loop. So I mean, at the end of the for loop body, we would have a jump, I guess, that goes back to the for loop. Actually, no. We have to go back all the way to here to check the check again. Yeah. So we would jump, and it's unconditional. So this would be null. I think that jump if, I'm not sure if jump if actually does anything if it's unconditional. Yeah, if it's unconditional, we don't even care about the jump if. Yeah. So this doesn't matter, and the place we want to jump to is the for label. So here's the loop. Basically, we start here. We check first if we need to go out of the loop. Otherwise, we loop here. Also, at the end, we want to increase. I guess we want to increase the counterf as well. So we want to do like, actually, oh. Well, actually, you know what? Let's just set R2 to be counterf, and then we do inc, because that will increase R2 by 1, and then we set this back here. Okay, so these three will basically increase the counterf by 1. Because I don't want to bother like adding support to inc to be able to increase refs as well. So we'll just use like, we'll set R2 to the counterf, we'll increase R2, and then we set it back. So now it's increased by 1. Okay. Dot R2. Trying out zig. Oh, cool. Wait, but did you change your name? Were you called said who? Have you been here the whole time? Because you did, yeah. Tizzy. I'm confused. Yeah, more people going into Zig. Awesome. Yes, okay. Now I'm not confused anymore. Because I was like, you're not the same person, so I have to ask you. You just change your name. How do you even do that? Like in YouTube? Member function, expect file. Operator left, right. Oh yeah, source. There we go. Okay. Wait, but this should... Okay, so I guess we'll try this and then return a void. No, we should just return not implemented. We should return this. Yeah. I think. Or should we actually? I would probably want to have multiple errors reported at the same time. Because this would kind of abort compilation. Yeah, actually, let's do this. This could technically, well, it was we are reporting errors, so it won't. Okay, yeah. Now the issue is that we don't actually return anything in the end. And the question is, what do we actually return? Also, we haven't actually compiled the body of the for loop yet. So that is also, we have just compiled the surrounding thing here. And we also have to declare. So basically what's left here is we have to declare identity. So we have to create a new scope for body. Declare bindings for captures, source captures. 3, compile for body in context question mark. We have to figure it out, and that's it, I think. And then it goes back here and increases counter, goes back probably as statements as well. Yeah. No, it shouldn't be in context actually. I think it's only gonna be as a statement. Yeah, I think so. We'll figure it out. So this is what we need to do here. And then, oh yeah, and also here we're gonna pop the scope as well. The bindings scope. Yeah. Maybe even a stack frame. I'm not sure actually. Yeah, because if you don't like restore the stack balance, and if we push a bunch of things in the for loop body, then those are not gonna refer to the same thing next time. Well, actually, It does. I don't think it matters. No, it does matter. It does matter. Yeah. Okay. And then what do we actually return as well? Like, what does a for expression return? Maybe we don't actually support that yet. It's gonna kind of be the same thing as binding to a block body. Does zig have discriminated unions? It has tagged unions. I'm not sure if that's the same thing. What does discriminated unions mean? Oh, it's the type. Okay, tagged algebraic type. Okay, yeah, so it's tagged. Yeah. So I guess the answer is yes. I can show you an example here. I don't know, animal. So this is how you do a tag union. So let's say we have a cat, and the cat could be anything. You can do this: cat, dog. Cat is a struct that has an age. Dog is a, let's just say a dog is an enum that is like, I don't know, why did I do this? Because I know nothing about dogs, especially in English. Okay, terrier, I don't know. Yeah, something like this. So this is a tagged union where you can have either a cat or a dog, and they could be different types as well. I mean, yeah, that's a union, of course. But the point is here that it's tagged, so you would be able to have a function that says well, let's just have a super simple thing like is cat, and you will get an animal and boom. Okay, and then we need a print or a semicolon, and then this would basically, how you would use it is you could do this. Doberman, German Shepherd. Yeah, thanks. So this is actually, it's really nice because if you get a value of this type, you can check what tag it is by doing this. And then you can even okay, I know one more. I don't know if that's correctly spelled. But let's say we have a function is animal small. Also, actually, you can have, what's also nice, really nice about Zig is that you can have functions on the union itself. So you can have a function here that is like is small, and then let's say, well, you have to have self animal, and then let's say a bool, and we return a switch. So you can, so I want to demonstrate how you can switch on the tagged union. So then you would have like dot cat, let's say all cats are small, and then dogs, we can switch again. Actually, you capture out the, what you call the different race, or what do you call it? I don't know. Let's just say race here. So if it's I don't know, a Chihuahua. Actually, these are, so commonly you would have a lowercase on this. I don't know why I put it as lower as, but you would say Chihuahua there, and this would be, I guess, true. Otherwise, false. So that's pretty cool, because then you can create an animal my animal is an animal, and let's say it's a cat, and you have to supply like an age or something, and then you can say like my animal is, no wait, no, that's not correct. It's an animal, there we go. Here's how you do it. Otherwise you create just the cat struct. Now we're creating the animal tagged union here. And now we have like animal is small. So when you do like animal dot, you get like either of these. But if you choose the wrong one, of course it's gonna be a runtime issue. But you can call this is small, and it will like give you an answer. And it stores in the same memory. Yes, so it's like a union in C, except this one is tagged, so it has extra information about the tag as well. But the size of the union here, the size of this is what is going to be the largest of the thing, just like in C. Yeah, in C you have to manually set the tag. Yeah, so this is like built into the language. And you can actually have unions that are not tagged as well. But I never use that because it just seems annoying. I mean, I guess there would be, if you really, really want to be very careful about memory usage, you could do that. So there are like C-like unions here as well, where you just have union. And it's basically you can do the same thing, but now you have to know which type it is before you use it. So that just seems inconvenient. But there are probably, let's say you have a list that everyone is a cat, then this would be slightly more efficient in memory. When you change the data, it overrides the whole union. Yeah, so as I said, the size of this type would be the maximum size of whatever subtype you have. So it would be either cat or dog, depending on which one is the largest. Now here they are probably the same size, and enum is basically just, I think it's like a U32 or something. By default. You can also change this to be like U8 or something if you want, I think. But I think by default it's like U32 or something like that. And U size depends on the operating system, is either 32 or 64, depending on if you're 64 bits, 32-bit, I think. So actually on my system cat should be larger, so that should be like 64. So the whole size of animal should be 64. If you supply it with a cat, it will overwrite the whole thing with a cat. If you supply it with a dog, it will overwrite the whole thing with a dog. Yeah. And I use union enums all the time because it's a really nice way to generalize functionality. It's like it's my favorite feature in Zig, probably. It's like tagged unions, and yeah, so enums and structs, and unions are new. So tagged unions are basically like enums and structs put together. It's like when you want to have something that can be different things, but you also want like generic functionality. For example, I have this list of instructions here. Where is that? Yeah. So here I have the instruction type, which is a union enum. So it could be either of any of these things. But an instruction is like a generic thing that has any of these types, but only one of them. And some of them can have no extra data. Some of them can have extra data that you need to to have. So yeah, a really good thing to have. And then also, of course, you can switch on it to get to what actually what tag you're looking at, and depending on the tag you're looking at, I mean, let's say we go to the evaluator, for example, and we have, this is like we're running an instruction. So you get an instruction in, and then we switch on the type, and depending on the thing, we do different things. I mean, it's pretty simple concept, really, but it just so nice way of doing things. And another good thing as well with Zig is that it forces you to exhaust all of the tags. So let's say we would, I'm just gonna check if we have an else here. No, we don't. So let's say we remove one. Okay, this will actually be a compiler error because you must handle all possibilities. And you might be thinking like, hey, that's annoying or something like that. But it's actually a really nice feature, because let's say you have a bunch of switches on this type, which you know, is a bunch of places where you implement that type. And so let's say you want to add another type. So I want to add my new instruction. Okay. Now you have to go and find everywhere to where you want to implement this. So basically, the compiler will tell you, hey, go here and implement this over here now. So you get this here and you can implement it directly. So I think that's a really nice feature to help you as like, where do I go to actually implement this now? It's just a nice safety thing. But of course, you can also get around it by having an else clause, which will capture everything, and it will prevent you from having that nice thing happening. But also, if you have an else where when you have all like cases handled, you also get a compiler error, so you can't actually have this else. So I'm just gonna remove that, but I don't really need it. But yeah, just to show that yeah, tagged unions are not only a really good data type, but it's also in Zig it has a bunch of utility with other features as well. All right. Right, so we need to return something. I think that for now I'm just gonna return from value void for loops, and we'll figure that out later. And I'll add a to-do here that says return something like the block compilation is doing. So basically, we probably want to capture everything that happens in the for loop somehow, and also return it the same way that the block is doing it, except the for loop is like it can do it over and over again. But yeah, okay, so let's just try and finish this off here. So create new bindings for the thing. So this will be, I think we have like scopes and then push. Here. Yeah, so we push a new scope, and then we also pop it down here. Okay. And we're gonna declare bindings for source capture. So the thing is here, yeah. So actually we have like binding. We have like compile binding. We can do compile binding It's not really a declaration. It's more like we're just binding, and we should have a pattern. So this should be like captures. That should be like for expression captures or capture bindings 0. So I'm just going to assume that we're just working with one capture here, since we're kind of forcing that compilation. We only allow one source right now. Okay, expression. Wait. So this is the pattern. What is the expression though? Good question. Okay, what do we do with the expression? We do a compile capture, and then we store the result source like this. I think this might be the only thing we need to do, actually. So you know what? I don't want to compile binding. I want to compile identifier binding. Okay, and then the identifier. I mean, it depends on the capture, I guess. Like if this is capture is Discord, we don't care. No, actually, I think that should be correct. Yeah. See? Also a union enum. So if the capture is a discard, actually, I don't think we really need to do anything at that point. If it's an identifier, we get the identifier. And then we compile this. So now we do have an identifier here. Wait. Oh, I see. This is a pointer, so you have to do this. Oops. Yeah. There we go. Now we get the identifier. Okay. Identifier. So the value here, what we actually store it as, is something. Yeah, I think this is interesting. I think we have to create a ref here to store the capture value as well. Capture. All right. Good luck, Titsy. See you later. I just realized I wasn't online on Discord. If you need any hint or anything, just hit me up on Discord there, and I can answer you when I'm on. Oh wow, it's lagging. Oh, Subhadra, I didn't realize. Are you blue? Oh, why Zig? Someone asked there. Because it's the greatest language to ever grace our minds. No, I don't know. It's very interesting language and it's really fun. And I've basically been hooked since I tried it. Like, I've been doing Zig for one and a half years now. Okay. Use of underground the result. So what is the result? Well, the result would be the capture ref, I would guess. I would say capture ref. But we don't want to actually create it here because we're inside the loop. We don't want. We could just. We want to create a space for it like before the loop. So let's do it here. And then here is like the identifier that we're getting. We compile the binding. We also set, yeah, no, but this is that's the binding. I think this has to be dereferenced. And mutable is not sure. I mean, I think in Zig it's not mutable. Actually, it depends. You can actually mark it as being mutable. I mean, I think this doesn't really matter too much maybe right now. I'm just gonna say false or true. Let's just say true. You can change it if you want. What about Rust? Based on what I've seen, it's just Rust without some stuff. Okay. I haven't actually tried Rust that much, to be honest. So and it's like, from what I've heard and from what I've seen, I'm just not that interested, to be honest. Like, I know about the traits system, and I mean, I enjoy that type of system. But then I think I would just wish that I was using Haskell instead, because that has a more powerful system that works the same way than traits. And yeah, I don't know. I mean, yeah, the one thing that I would be interested in learning more about would be like the borrow checker stuff and how that actually works, because but also, like, I'm not really doing that much you know, multi-threading stuff like that, so I don't know. Rust really just, it doesn't really speak to me the same way that Zig does. But I mean, I think that at some point I would probably try it more seriously, just to, you know, been there, done that kind of thing, to get a more feel for it. But yeah, I'm just all in on Zig right now, so Zig is probably going to be one of those languages that I always like get back to. Like, I do some detours and then I go back to Zig, probably. And I think that if you want to compare Rust to Zig, now of course I'm not a Rust expert, I'm not a Zig expert either, but from what I understand, like, if you want to do things properly in Rust, there's like a lot of ceremony going on, while in Zig the same thing could potentially be a simpler implementation, because there's no like rules to it. I don't know. That's just my initial feeling on that, but you know, keep in mind I haven't actually tried Rust very much, so and I'm nowhere near like an expert level on Zig or anything like that, so I can't really compare the two, but yeah. Anyway, maybe in the future I will know more. There's probably a bunch of resources that compares the two, but yeah, I haven't checked it out or anything that you could look up, perhaps. Yeah, sorry, I just don't know. Switch must handle all possibilities. So yeah, so Discord identify. Oh yeah, so we have like tuple and the other things. I'm just gonna say that these. Wait, what was it? Tuple and record, right? And these, I mean, yeah, I'm just gonna say unreachable because we don't really support those right now. And I don't care to deal with that. We won't ever get these right now anyway. So expected type, value source, found location. So this will be just from. Okay. Expected error unit I found. Right, so it's not an error, so we can do that. All right. So. Let's see. So we have a new binary scope. We declare inside the scope. We declare capture if we have one. And we compile, but it's so also I missed a step here because we need to also set capture value for iteration. So we need to set. Also, this should, I mean, this should probably only happen if we actually have the value in a binding. So I'm actually only gonna include it here because if we discard it, we don't even need to worry about it. So I'm gonna set it here. So we wanna set capture ref. And what do we set it to? That is the question. So this is how do we iterate through the array? And well, we can do, let's see, we can set R2 to the location of the source. We can use R2 here. I should make another register called D2 so we can set R2 to D2 and so R2 equals from location there, yes. Actually, now we don't dereference. So we just do that. Now R2 is set to the pointer of the source ref. Right, so then undo reference. Actually, we could also do init add here, I think, at this point. No, you know what? Since this is a ref and we deref that, we would actually just get the pointer to the array. Yeah. So we have to do this. Now we can actually, yeah. So now we set this to from location init add register R2. So we add something here, except no, this doesn't work because we had this is add is like com time now. Like we cannot actually add another. What you could do is you could say like arithmetic. Like we could do this. Whoops. Yeah, it's basically the same thing, except do we have ath operator binary? No. Yes. Yeah, basically this. And then we go back to here. We can do this. Okay. And that is basically what we want to do here. So first we set R2 to the pointer of the array. Then we want to add R2 and I guess this would be like the counter ref and we store the result in back into R2. Alright, see you later, Penguin. Welcome back, Mutasimos. Sorry, I think I missed a couple of messages. The dot brace syntax confused me so much. I mean, yeah, if you're not used to that, you have to kind of get used to it if you want to start using Zig. I was not used to the whole dot blah 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 dot blah 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 syntax either. I mean, I was used to member access, you know, if you have like a class something dot something else, but not like this, like when you have dot at the start and then dot like this. Yeah, so this took a bunch of, like, because I'm also used to like JavaScript objects, so I would constantly write, instead of this, I would write like this. But then I've actually trained that away, so I don't do that anymore. Basically, it was a long time since I've actually done that mistake. But yeah, this is, you know, kind of like creating an object almost, except it's typed. So, well, of course in TypeScript you would kind of get the same thing, but dot here, I would see dot here when you have like dot brace as meaning kind of like an alias to mean like any or like auto type. So it fills in the type, because what you can do here is you can have a type here instead. So that's how I see it. Like you can have a type, and then this would be the struct type here. And if you have a dot, that basically means infer it. Yes, type infers, exactly. So this would just infer the type that you have, that you want to have. However, you can also just have, you know, you can also just do well, you can do a tuple like this, but you can also have a, actually we need dots here. You can have like an anonymous type here. So this doesn't really, it's not a named type. So this would be like an anonymous type that would be granted to this X here, but it would still work, I believe. So, well, the LSP kind of freaking out here, but I think this should work. So this doesn't actually have like a typed out type, but this will become an anonymous type that is inferred by, you know, the values that you give it here. And then of course the fields always has to be dot something. Another way to think about it is that this dot here is also like, you could think of it as having an invisible of the struct type before it. So this would be like, let's say this is location abs. So this would be like location abs dot register. It's kind of like having an invisible. Now this is not proper syntax here though. I don't think you can have a syntax like this, but it's basically, it's, you know, this is kind of how you have to think about it. Because, and there's another reason why you would think about it that way, because this R2 here is kind of like that. This R2, you can say the type of this is actually an enum type. So register abs. Now this actually, you can type it all out like this. But if you just type R2, Zig will infer, well, it knows what the type should be. The type should be register abs because we're trying to assign register here, which is that type. It's the register abs type here. So it knows what fields or what enums there are on that. So you don't have to type out the whole type dot R2. It can actually just, you can just say dot R2, which I think is extremely nice. And also, not only that, but if, let's say you have, let's say we have a function here, which is like, I don't know, some function which gives you register abs, and I'm just gonna say R2 here. I'm just gonna say general register. Yeah. So let's just say you had a function called general, which is defined on the type, and it returns the type itself. Well, then you can use it also here, dot general, which means that you can, you know, you can have a very convenient way of like initializing different values, where you don't have to type the whole type out to initialize the value. You can just say dot whatever, and it will kind of yeah, wire that up for you there. So I think that is also extremely nice that you can just do that. Zig has a lot of anonymous things. Well, yeah, but they are all, everything here is like, yeah, it's anonymous, but it's also, it also is like a strict type. So it's not like it's wiring up all these anonymous things. It's more like it's inferring the type based on what you're trying to provide into. So for example, this add function, you want to have this type, so the first thing that you provide here is going to be that type, you know. So it's not like it's an unknown type or an anonymous type or anything like that. It knows what type it is. It's just that you don't have to type out the whole type when you want to like create a value for it. Zig looks like Rust but lower level to me. Okay. I thought that Rust was also like very low level and also manual memory managed. I would say they are kind of the same thing, except you know, they are a different set of features, different philosophies when it comes to building programs, is my understanding of it. But yeah, very good question. Like, yeah, the dot thing is very interesting, and you know, you come to you know, get used to it when you work with it here. Okay, so let's see. We're trying to set the iteration capture here. So we're using R2 to set the source f, because we know it's an array, so we grab its pointer here, and then we just add we add the counter to it. Now we also have to add one more because the array, the first element of the array is the length of the array, so we have to skip that as well. So we add the counter to R2, and then we increase 1 as well to R2, and then we set the capture to be what? I think it's just gonna be R2 dereferenced. Yeah. So this would be register R2 dereferenced true. Okay. So now we're taking care of actually getting our iteration value out and set it into this stack location. And I think the only thing left now is compiling the body of the for loop. And we need to compile it as a statement because each iteration needs to wait. We need to wait for that to finish before we iterate through the next one. So we're gonna do a compile statement. I think. Well, it's actually gonna be an expression that we pass in. So actually, do we have like compile expression with? We have with capture, but we're no. How do we do this in the other place? Which place am I talking about actually? I don't know. Well, this is the block statements, but it's not necessarily that. This is the whole thing. Okay, so we actually don't have another place where we do this. So the reason why I want to do compile statement is that we have this waitable functionality here. But I think that we can just do this manually. So it's like we get the body result from compile expression. The expression is for expression body, and then we check if that is waitable. If it's waitable, we wait for it and then continue with the for loop. And this would be the source, I believe, yes. Okay. All right. I think that's it right now. So this would support for loops, but only for arrays and only for one array source. So let's try this out now. Let's do IR4 and so, okay, Mute Simos, how well versed are you in Rust? And what other languages have you tried, or are you do you know about, or have whatever. I just want to see like. Because it's interesting. Like I have experience in a bunch of different languages, and Zig is like it kind of stands out to me somehow. Even if it's like it's you know it's kind of the same as C, but with a different syntax and different features. But also one thing that I haven't shown you is like the comp time stuff. The comp time stuff is different. As like Zig doesn't have the macro stuff in Rust that Rust has, but it does have comp time stuff. So, which is also something that you have to get used to, and it's very confusing at first, but after enough banging your head against the wall, you get it. I say I'm an intermediate in Rust, and also programming JavaScript and Python, sometimes mod micro with Java. Okay, cool. Yeah, so yeah, I would like Zig is, to me, Zig is like pretty unique language. Just because of, I think when you take like everything together, to me it just becomes a unique experience. But maybe you get the same feeling from like, I don't know, low level C or something like that, which I haven't really tried that much. But yeah, let's do a for loop here. So we'll do, so first we have to create an array, and let's just do like, I don't know, 3, 4, 5 to have something different there, and then we'll loop through that. We'll get the element out, and let's just try with a normal expression here first. I'm just gonna say element here. So let's just run this and see if it works. Of course it doesn't work. Okay, we got a memory leak. Label address not set. Right. Memory address not set. Yeah, makes sense because we never actually, we have this label here that I forgot to set this after label. This is supposed to exist here, but then we also need to set where it's supposed to be. It's like a lazy address. So it's gonna be, it has to be over here then. So I forgot how you do this, but after label, I'm gonna go to compile if to see how we did this. So after address, so that's the label. Jump to that. Set label. Okay, so let's do this. Set label. There. Okay. Now let's try. Okay, we got an error. Unsupported binary expression. Interesting. Where is that happening? 01B. Okay, unsupported binary. We're setting R2 to be 4 counter less than iterations. Let's look at what those stack values are now. 7 and 8, right? Yeah. I mean, 0 is less than 3. That looks correct. What would the binary operation be that is not supported? Not sure. Because they are both U integers. Low-level Rust is just writing unsafe everywhere until the compiler shows up. Okay. All right. So does that disable like the borrow checker and stuff like that? Because I actually did try Rust once, but I quickly ran away after it was just yelling at me for all kinds of things. I was trying to do like a web server, just a basic thing, and it was using like some kind of well, I was following some kind of guide or something. I don't know. I don't remember. But or some. Yeah, I think I was just looking for like Rust web servers, libraries, and I just picked one, and I just tried to do something, and it just didn't work. And I had no idea how to fix the issue. So then I was like, okay, well, I tried. a bunch of stuff, but I didn't get it to work, so I couldn't really understand how to fix the issue. And I realized that, yeah, I have to kind of read a book or something about how it works, because, yeah. But I wasn't up to that, so that was the end of my Rust experience. You can disable the border checker with raw pointers, and raw pointers are unsafe. Okay. Yeah. I understand. And then you would lose some kind of safety thing. But, I mean, I would like to learn how to do it properly at some point. But right now, I'm not super interested. Okay, so this... No, that was not the issue. Okay. Oh, maybe it was like a later iteration or something. Right, arithmetic, increase, set the capture. So this is interesting, because now we can see that the capture should be set to the next thing. SF plus 6 is 3. Oh yeah, that was the first element, so that looks correct, I think. And then you do a bunch of stuff. And okay, so that actually, then we should actually get like, we get back here, and now let's look at the stack again. Okay, here we go. No, wait, yeah, so here we go. So 8 is now different. 8 is 4 iterations. So why would this be set to something else? That is not great. Yeah, so this would not work here. Okay, so something is like overriding this stack value. All right, yeah, I'll also BRB 1 second here. I'm gonna refill my coffee. Be right back. All right. Okay, so what could that be? Let's go here again. 1B, was it? Yeah. So I wanna see where that happens. I wish I had like a watch feature to watch this stack value, but I don't. We could build that, I guess, but because then, you know, it would save me some time. It would, I mean, it would be cool to have like, well, break when this actually changed value or something like that. That would be cool to have. Okay, so R2 points at, well, R2 is 0. Here we're just setting R2 to be something else. 4. And we add some counter, which is 0. So then we increase. Yeah, so that is now we set to the first iteration there. Okay, so now we're setting SF plus 9. Okay, cool. Closure plus 1 equals R. Closure 1. So the closure right now is 4. And we have one variable which is points to 8. No, closure was 1. Yeah, so this points to B, which points to 9. Okay. Welcome back. How many lines are written for Runic? I don't know. But I've been working on Runic maybe since maybe a couple of months or something like that. Like 4 months maybe. Like not maybe every day, but here and there. But I feel like I have, when the for loops are in, we're gonna be pretty close to the first MVP version. And it's like the first alpha version, I would say, something like that. It's like, I would say like, the first version is going to be when I can sort of use it to replace Bash for my own personal use. So that's the whole reason for the language, basically. And also having fun actually learning and making the language as well. Are you trying to build a programming language SMTG? I don't know. I've never heard of that. SMTG. Also, well, I would say that... or do you mean something, maybe? I did not look up any like alternatives to Bash before I started, because I wanted to make it like without being tainted by any ideas or anything. I just wanted to make like how I wanted to make it, basically. Because then I might be tempted to not make the language and just use something else instead. But no, I think it's really fun to do this. Okay, so we have another ref closure saved R. So that is set as A. I want to keep a close eye on 8 here, because at some point that will be overwritten for some reason. Plus B, we set R, now C. Okay, R plus 1, yeah. Okay, 1 second here. I probably won't like I will just try to fix this issue, and then I will have to go here and eat something. Are you trying to build a program? Say yes, that's what I'm doing. I'm building like an interpreted language that uses an IR language that is, so basically you have the scripting language that is compiled into an IR language, and the IR language is the actual language getting interpreted. So and that's what you see here. This is the IR language here, where we have like set, fork, and all these. Like these are instructions here that we compile it into. Right, so we set fork. Now this fork we shouldn't really care too much about. It doesn't really do much here, I guess. Here we do pop. So here's a bunch of pops. Let's look at how many things we have. So we have like 3 extra things. So popping those 2 is fine. But then we also create a new thing there, which is +A. And here we have +9. Okay, let me check. This still is correct. Okay, and then we pop twice. Okay. And we wait for this, which does a bunch of stuff. And that one is done, and R2 is now set to, so R2 is 5. R2 is set to the counter. We increase. So I'm confused. Now 8 is still 3. At what point does it change? Okay, here we go. Set 4 iterations equals R. Oh, this shouldn't happen again. This should only happen like once. I see. Right. So this thing, this should happen like outside of the loop, but it is happening outside of the loop. What the hell? Wait, is the for label, is it jumping to this? I thought it would jump to here. Compare. No, wait, we have the set R2 counter F increase set and then jump. Okay, I see. I think the issue may be that the label is actually jumping us here and not over here, which I would assume. Okay. So I guess it would be, the label has to be over here. Okay, now we get another error. I think we also show where the label is. So the label should be up here somewhere. No, that's the identifier of... Wait. Where is the thing? 4 counter, 4 iterations. Compare. No, okay, maybe it wasn't shown there. 4 after. Okay. Well, let's just continue again. Okay, so now we get an issue here. Why do we set again? We shouldn't get here again. I don't understand why it's going back here. Okay, let's look at the compiled instructions. And I want to go to the jump. And this, of course, goes to after. This goes to 4.1. Okay, here we go. 4.1 is apparently set over here. And I don't understand why. It should be over here. But for some reason, even when I move it, it's like still in the same place. That's weird. Yeah. Wait, so if I move it, let's say I move it up here, does it move now? Okay, it does move. Okay, so it's a little bit unaligned is what I'm seeing here. It's a little bit, for some reason, it's not really aligned. Why? That would cause like all labels to be slightly off. Like it's too off here. Is it because of the closures? I'm gonna try. Let's say we have like a mutable variable over here, because that will affect the closure. No, it still has the same place. Because now we have like a closure that's being set here. So we have like more instructions being inserted over here after the fact. If you remove this, there's less instructions over here, but somehow this still is on this one. So it's like set up here. I've been working on a Minecraft clone in Rust since November. I really like graphics programming. Oh, nice. Mindplace 3D, that's what it's called. It's not as impressive as other voxel games, but sure does have a lot of silly stuff. Cool. That's awesome. Alignment is scary. Yeah, I mean, it's like the way I'm kind of dealing with this here is not trying to get like a super robust engine running here. I'm basically just making a bunch of tests to see if things work, if they still work after I change something. Because because it's really just a huge spaghetti engine here, it feels like. But yeah, well, hopefully we'll get it to work here. How did you get the custom syntax highlighting for Runic? So I'm using like this text editor is NeoVim, and I implemented a 3-seater parser for the language, which is not totally up to date right now, but it does work for most things. So that's what you see here. We also have like an LSP as well, so you can. Well, okay, it doesn't work right now. It basically it kind of works sometimes. What if we just have like basic? No, bindings. Basically everything here has a. Let's just wait. IR basic. Let's just do like IR basic binding. So constant x is an integer, which is 3. So, okay, that doesn't work. I'm just gonna restart the whole thing. Okay, now you see. So the LSP does work, but it's very unstable, and it's a very basic implementation, but it doesn't require much to make it like not work. But it also it like coexists with a type checker that also type checks stuff. So if you would say, if you had a string, let's say hello, I think this should work, yeah. And then you say like, well, now I want to set x to, or set s to x. So that would not work. Okay, maybe I haven't implemented that part of the type checker, but this should produce an error, I believe, or it doesn't. Okay, well, let's say let's do this now. Okay, interesting. So that example did not work, but it used to have like errors happening. No? Okay. Well, anyway, so I need to fix that as well. But yeah, the syntax highlighting is basically a 3-seater. I believe we have like grammar.js. So you have to define a bunch of parsers. I basically used AI to do the scaffolding here, and then I added a little bit myself. But this is not really up to date. But basically, you have all these different rules, and yeah, I really like, by the way, this type of parsing system. Like, this is what I'm used to, like having, you know, a very, like, you have this choice, sequence, optional. Like, I just really like this way of defining a parser. But anyway, that's 3-seater, and then you have a highlighting rules. Basically, it's just mapping the names of the parsing rules to built-in, you know, things in NeoVim. So that would automatically wire up the correct highlighting for you, basically. You know, you have like a Boolean literal. Okay, we map that to Boolean, which would just have it. And if you have the, you know, if you have a color scheme that implements highlighting for Booleans, this would now work. And so on. This one was the most. This one here was the. This one was the hardest one to do, because this one is like everything else was basically just mapping one to things or another. This, like when you have like interpolation, this still doesn't really work. By the way, it still doesn't work. You can use this embedded thing for like expressions inside interpolations, but it still doesn't really work. It's supposed to like wire it up to be Runic inside, but then the syntax still doesn't really work all that well. But yeah, everything else works really perfectly actually. So yeah. And of course the LSP, you can work with like auto completions. You know, we have like I have very basic auto completion right now with, you know, const var, like these keywords that you can do and things like that. But yeah, so yeah, that is that. All right. So why is this address not correct? I mean, it could just be the closure thing. It could be because the closures like add instructions after the fact. And then all addresses actually needs to be realigned. That is an issue. I think if we go to maybe then compile initial and we remove this closure here and hang on, this doesn't do much. I don't remember how this was supposed to work. So this returns the closure, yeah. And then we use that somewhere over here to compile the thing. So we compile the whole program and then we compile this, which basically it inserts instructions, 2 instructions in fact, after the fact. So all instruction addresses need to be aligned now with this. I mean, I think there's no reason why we couldn't just do this directly. There's no conditional thing happening here. Instructions, we already know, like we have, the only thing we don't know is the number of things we need to store in the closure. I mean, also technically that could actually happen in a separate instruction set. Actually, but it's just annoying. No, that doesn't work. Well, no, it kind of works, I guess. It could work. Man, this is okay. This is actually, this puts a spanner in the works here. It's like we don't actually know the address until after we compiled everything, because we don't know which mutable variables we need to have space for, and all of those actually, no, we don't actually set them here though. Ah, I see. So this will always be 2 instructions. It will always be 2 instructions. So actually, and they are inserted at the closure index. I think what we'll do is maybe we could alter the, no, but we will have the same issue with other closures. Oh my god. Okay, one solution would be to create a separate instruction set, and then you jump to that, kind of like a function in assembly. So you would jump to a separate place which is not part of this set, and then basically just jump back. I mean, yeah, we could get rid of this, these two. The problem is the other closures, because they have a variable number of instructions. It's kind of weird. Why would we do plus? See, yeah, this should really just be 2 here. Yo, cool guy. I tried using Arch Linux on VM where it lagged as hell. Maybe I have a dumb system. Man, yeah, I also tried. I don't remember what program it was. Maybe it was VMware. I don't remember. To install, but I always run into some weird issues when trying to install Linux on those things. So the thing about Mindplace is that the commit messages in Git are so bad that I get confused sometimes. My contributor friend constantly urges me to comment my code. Oh no. Yeah. I think, I've learned to comment my code if I have the, I've learned from my mistakes. Basically, if I create something and I look at it and say that, okay, well, this will become confusing once I forget about how this works, then I usually add maybe a little bit of comments to explain why is this here, because this doesn't feel, if you have a line of code that doesn't feel like it belongs there, I usually add a line of code explaining why it's there. It usually doesn't happen, like happens very rarely, but it's just sometimes that, okay, if I'm gonna come back to this in 1 week or something, or a month or something, I would have no idea what the hell's happening. Did you try anti-gravity? No, I haven't not. Actually. I'm using Codex for is it Google anti-gravity, or what is it? Google? Yeah. I mean, I feel like this is more catering to maybe non-developers. I don't know. I can't say. Maybe that was too harsh. No. Actually, but it looks cool. I'm actually trying to develop a thing right now where you basically you can create projects with AI. Like Codex is the backend that I've chosen to support right now. So basically, you would create, like, it's basically for developers. So you would create a project on your local machine. You would like spin up this server on the local machine that has access to Codex and that. So and then you would ask it, hey, I want to create a new project, and it would ask you some suggestions, like, okay, what kind of project do you want to do? It could ask you like questions, and you would answer like a form to give it more information about what to do, and then you could say, okay, well, now let's start the implementation. But so basically it's kind of like a feedback loop idea, where first you start by saying, hey, I want to create this project, and then you figure out, okay, the planning part, like, okay, what kind of project would it be, what is the scope, etc. And then you could start the implementation. So then, you know, the AI would actually start to implement the project, and that would give you suggestions on what to do next. So we give you a bunch of choices, basically, that you just pick one, and yeah, let's go with that, and it would start working on that, and then it comes back to you, and you would get the next thing. Okay, well, yeah, let's start working on the next thing. Or you can do like a custom prompt as well. And anti-gravity kind of sort of looked a little bit like that, except it was like a full IDE and stuff. I don't know, maybe it's very different, but it looked like it could do a lot more than just show the code and like cursor, have like a cursor thing. My commit messages usually add more blocks, remove devious code, aggressively optimize vertex attributes. I mean, sometimes I get super lazy with commit messages. I think that commit messages are I never kind of read commit messages. The only place where I actually are interested in reading commit messages is when you want to figure out when a change happened, and so the commit messages was, if you, like, let's say you want to debug some change or some error that happens, so you want to see, okay, when did this change, who changed this, or, well, maybe not who, but what changed and when. So you want to see, like, what is the cause of this issue. Then commit messages would be one way of checking, like, what was actually changed, so you can kind of parse that. But now it's like, okay, well, you can probably just ask AI look into the Git history to find where this happened instead. So I think the commit messages are probably not super important, not to me at least. But I mean, some people use it to figure out stuff, but I don't know. Sometimes I get super lazy with commit messages. But now I just ask AI to write commit messages for me. So anti-gravity does everything in just prompts matters. Okay. I add my commit message like updated UI, part of UI, create new feature. Yeah. So I don't even write commit messages anymore. I just ask AI, hey, could you commit this and create a commit message for me? Because sometimes you've done like a bunch of changes, you don't really remember what you've done, and I don't want to spend the time looking through the code. So then AI is very good at that. It's very good at looking at that and then just summarizing. So that's actually kind of like a perfect suitcase or a use case, suitcase for AI to like a task for AI. Okay, I don't think we'll get to this. I think I will write this down in to do, and maybe, I don't know, over here. Actually, let's go to for loops. Actually, no. Well, yes, this is kind of part of it. Okay, so labels. Okay, I'll put it up here. Labels have the wrong address if we have closures, since closures alter addresses after the fact, by inserting instructions. So we need to solve this somehow. I have a couple of ideas, but it's annoying. So I won't solve it now. But yeah, I really have to go now. So yeah, thank you very much for watching, and I'll see you later.